In this video, we will talk about the order of this cell average that we introduced in previous lecture. So we have to apply the Taylor series over here. The question is, if qxt is a smooth function, it means that we can differentiate this function many times as we like, and these derivatives are continuous. Then you can apply Taylor series to prove that this cell average has order of delta x square. So we see that if we have, for example, this I plus 1/2, I minus 1/2, this was over volume or cell. The value is on this cell is Qn I. We need to show that it has order delta x square. The midpoint of this cell is this I. This can be represented xi minus 1/2 plus xi plus 1/2 divided by 2. This is the midpoint. So we need to show that the value of this q at this midpoint has order of delta x square. This is very interesting problem. So we apply Taylor series. Qxtn is equal to Qxi Tn plus Q dash Xi Tn. And remember that we are talking about an nth level. X minus Xi plus Q double dash Xi Tn divided by 2, x minus xi whole square plus order of x minus xi cube. So we use this formula of Taylor series. Remember that for Taylor series we have different formulas. One is f of x plus h, f of x plus h, f dash x, h square by 2 factorial f double dash x. This is one of the formula. Another formula is f of x is equal to f of a plus x minus a f dash a plus x minus a square 2 factorial f double dash a. This is another formula. We used this formula over here. You must be wondering, there is only one variable, but here we have two variables. But remember that this Tn is already a constant. So this q is a function of x only. That's why we have only Taylor series for one variable. Otherwise, we have another formula for two variables which look like this. But we don't have two variables. We have only one variable Tn over here. So what we do, we just integrate that. Since in our question we have to integrate over qxtn at the midpoint xi over ci, which is the cell. Okay, so we integrate that xi minus 1/2 xi plus 1/2 qxtn dx is equal to xi minus 1/2 xi plus 1/2 qxi tn dx plus xi minus 1 half xi plus 1 half q dash xi tn x minus xi dx plus, and the last term, although we have, this is the last term, but the order is x minus x cube. The order of where we leave all the terms are cube. So this is xi minus 1 half xi plus 1 half q double dash xi tn and x minus xi whole square dx. So we need to solve this equation. The left hand side remains the same, ci q q x tn dx. I used ci for the cell value, for the cell. On the right hand side, since q is a function of xi, xi is constant, tn is also constant, so we keep this xi tn outside of the integral. So what we get, xi plus 1 half minus xi minus 1 half. This is actually the length of this cell, which is equal to delta x. So we can write this as q x I t n delta x. Remember that we have a uniform width. We can take a variable width, but it is not required here anymore. We will talk about that maybe in future if needed. And the next thing is we have to solve this second integration, and this second integration has a constant value. This is a constant which can go outside of the integration, but this x minus xi has actually, it is an odd function. And you remember that when you have an odd function over the periodic domain, then you can put that value equal to 0. So this will be equal to 0. Okay, so this is 0. Next is the leftover is this term. So we solve this as well. Q double dash xi tn ci x minus xi whole square dx, and order of x minus xi whole cube. We integrate that right hand side, qxi tn delta x plus q double dash xi tn, and this will be equal to x minus xi cube divided by 3. And remember that one thing, actually I missed it over here maybe, and what I missed over here, this is 2, q double dash divided by 2, it should be divided by 2. So I can write this outside 1 by 2, and here again I have 1 by 2, and then again we have 2. Okay, and then we apply the lower limit and upper limit xi plus 1 half. So this is equal to q xi tn delta x plus q double dash xi tn divided by 6, and we put upper limit xi plus 1 half minus xi cube divide cube and minus xi minus 1 half minus xi cube. There is less space left, so I will solve it in the next page. So what we have, I need to copy that, I need to finish that as well over here. So we copy, and take it to the next page. Paste. Okay. So this is Tn, so on. So we have Q xi Tn delta x plus Q double dash xi Tn divided by 6. Remember that we had a cell I plus 1 half, I minus 1 half. This is actually xi minus 1 half, this is xi, this is xi plus 1 half. So if this complete is delta x, this is delta x, so this will be equal to delta x by 2. So we can write this as delta x by 2 whole square minus and remember that if this is delta x by 2, that will be equal to minus delta x by 2. So we have plus delta x by 2 whole cube. This will be whole cube. Okay. So we can write this as a neat delta x by 2 whole cube plus delta x by 2 whole cube. And we solve it. Q xi Tn delta x plus q double dash divided by 6. So we have delta x cube by 8 plus delta x cube by 8. We can further simplify it. Qxi Tn delta x plus q double dash by 6. So that will be equal to delta x cube by 4. So Qxi Tn delta x plus q double dash 24 delta x cube. What was on the left hand side? On the left hand side we had xi minus 1 half, xi plus 1 half, qx Tn dx is equal to qxi Tn plus q double dash 24 delta x cube and order of delta x 4, and delta x4 will be equal to 0 due to the odd function, that will be equal to delta x5. In order to get q and I, what we do, we divide this whole by delta x. So we get 1 by delta x, xi minus 1 half, xi plus 1 half, qx Tn dx is equal to, there is delta x, I missed it, qxi Tn, and we divide this by delta x, we get q double dash 24 delta x square. So the left hand side becomes the definition of the value of q on the cell q and I is equal to, and it is equal to qxi Tn plus order of delta x square. Remember that whatever is left in terms of delta x has been considered All the other order delta x 5 and 7 and 9, all the odd values have been neglected. We have to pick the least value out of all these. So you can see that Q and I satisfies this equation only when we add this term. This was actually a proof that we have order of delta x square. Thank you for watching.